Your compass is lying to you. The magnetic North Pole has moved over 2,200 kilometers in just 190 years, and in 2025, for the first time ever, it officially crossed out of Canada and into Russian territory. This is not a prediction. NOAA confirmed it this year. I was reading the official NOAA annual report from January 2026, the same document used by military pilots and GPS engineers, when one number stopped me cold. The pole is drifting at 36 kilometers per year. That is faster than any point in recorded history before the 1990s, and most people have absolutely no idea. What the headlines are not telling you, this pole shift comes with a second, more serious problem over the South Atlantic, a growing hole in Earth's magnetic shield that ESA confirmed expanded by nearly half the size of continental Europe between 2014 and 2025, the real documented science, what it means for satellites and navigation right now in 2026. That is what we cover today. The magnetic North Pole is not the same as the geographic North Pole. Magnetic North is a dynamic location where Earth's magnetic field lines point straight down, and unlike the fixed geographic pole, it moves continuously. This field is generated about 2,900 kilometers beneath our feet, where liquid iron in Earth's outer core flows in complex currents that create a planet-wide magnetic force. Think of it as a giant natural electromagnet, constantly churning. Because those deep iron currents constantly shift, the pole above them shifts too. It always moved slowly, but the speed changed dramatically in the 1990s, and scientists are still working to fully explain why. For most of recorded history, the magnetic North Pole drifted at about 15 kilometers per year across the Canadian Arctic. Explorers in the 1800s located it, scientists tracked it, and the whole world built navigation systems around that slow, predictable pace. Then in the 1990s, the speed more than tripled. By the early 2000s, the pole was racing at nearly 60 kilometers per year, 4 times its historical average. In 2019, NOAA had to issue an emergency update to the world magnetic model because navigation systems were drifting past their acceptable error limits. Today, the drift has eased to 36 kilometers per year, still well above pre-1990 norms. And as of the 2025 World Magnetic Model, confirmed by NOAA in January 2026, the pole is now officially closer to Siberia than to Canada. The pole entering Russian territory for the first time in 190 years is not just a geographic milestone. It carries real consequences. Every aircraft, ship, and navigation system on Earth calibrates against the World Magnetic Model, which tracks exactly where magnetic north sits. Even a few degrees of uncorrected declination can throw off flight paths and shipping lanes. That is why the 2025 NOAA release introduced WMMHR 2025, the first ever high-resolution magnetic model, improving accuracy from 3,300 kilometers down to just 300 kilometers. Some Arctic airports have already had to rename their runways because runway numbers are based on magnetic compass headings, and as the field below them shifted, the old numbers became inaccurate. The world is physically relabeling itself. Geophysicist Philip Livermore at the University of Leeds published findings in Nature Geoscience, identifying the most likely cause. 2 massive regions of magnetic flux deep inside Earth, one beneath Canada, one beneath Siberia, locked in a slow, powerful competition. ESA swarm satellites, measuring Earth's magnetic field continuously since 2014, confirmed it directly. The Canadian lobe has been weakening while the Siberian lobe intensifies. Between 2014 and 2025, the Canadian lobe's field strength measurably dropped as Siberia's grew. As the Siberian lobe strengthens, it pulls the pole toward it, like a tug of war 2,900 kilometers underground. This is why even the world's best models sometimes need emergency updates. The forces driving the shift are simply too deep and complex to predict perfectly. Separately from the pole shift, A different problem is growing over the South Atlantic, and new 2025 data shows it is accelerating. It is called the South Atlantic Anomaly, a vast region where Earth's magnetic field is far weaker than anywhere else on the planet's surface. A study published in Physics of Earth and Planetary Interiors, using 11 years of ESA swarm data, confirmed the anomaly expanded by an area nearly half the size of continental Europe since 2014. Since 2020, the weakening has actually been accelerating near Africa. Lead researcher Chris Finlay of the Technical University of Denmark described what the data revealed. Field lines beneath the anomaly are bending back into the core instead of emerging normally. This unusual reversal is what is driving the accelerating weakness. Earth's magnetic field is a planetary shield. It deflects high-energy solar particles before they reach us. Where the field is weak, those particles penetrate deeper, and any satellite passing through that zone flies directly into elevated radiation with almost no protection. NASA has documented real hardware failures linked to the South Atlantic anomaly. Satellites experience data corruption, computer glitches, and temporary blackouts when crossing the region. ISS crew are advised to avoid spacewalks when passing over it. NOAA's 2026 annual report confirmed the anomaly grew by 8% in the past year alone. With thousands of new satellites now in low Earth orbit, the anomaly's growing zone intersects a rapidly increasing number of orbital paths every single day. Most people assume GPS is immune to magnetic field changes, but ground-based correction systems that keep GPS accurate do rely on precise magnetic field models. When the field shifts faster than models predict, small but real errors begin to accumulate. For most users, those errors stay invisible. Software updates absorb them quietly. But in polar aviation, maritime routing, and military operations, the margins are tighter. That is exactly why the 2019 Emergency Magnetic Model Update made international headlines. WMHR 2025, released for the first time ever in 2025, improves magnetic accuracy from 3,300 down to 300 kilometers. NOAA is actively pushing all high-precision navigation operators to switch to this upgraded model now. Dozens of species, migratory birds, sea turtles, sharks, salmon, navigate using Earth's magnetic field as an internal compass. Decades of experiments confirm they detect field strength, inclination, and direction with remarkable biological precision. Studies in current biology link whale stranding events to days when elevated solar activity disrupts the magnetic field. The animals follow field lines that, under disturbed conditions, lead them into shallow water. A documented, measured connection, not speculation, as the pole shifts and the South Atlantic anomaly expands. The magnetic map billions of animals evolved to follow is being quietly redrawn. This is a real, ongoing ecological concern backed by published research. This question deserves a straight, evidence-based answer. Yes, Earth's poles have reversed hundreds of times. These reversals are recorded in ancient volcanic rock and are scientifically confirmed. But the critical question is one happening now? Experts who built the 2025 World Magnetic Model were clear. No evidence points to an imminent reversal. The field has weakened by about 10% over 2 centuries, which sounds alarming, but sits within normal historical variation. Any true reversal takes thousands of years. What scientists are genuinely watching is whether the weakening Canadian lobe, the growing Siberian lobe, and the expanding South Atlantic anomaly together signal a temporary fluctuation, or the early stages of something longer term. The next satellite generation will decide that. Earth's magnetic field is the first line of defense for our entire surface infrastructure during solar storms. Power grids, pipelines, undersea cables, and radio systems all interact with the magnetic environment, and a weaker field lets more solar energy through. The 1989 geomagnetic storm knocked out Quebec's entire power grid for 9 hours, leaving 6 million people without electricity, and that happened with the field at roughly its current strength. A weaker field would let a comparable storm penetrate further. Grid operators across North America and Europe are now required by regulation to assess geomagnetic storm risk in their resilience planning, a direct result of documented magnetic vulnerability. A changing field makes that planning more complex every decade. NOAA and the British Geological Survey update the World Magnetic Model every 5 years and have built in an emergency trigger for interim updates if the pole moves faster than acceptable error margins. The January 2026 report confirmed the current model is within limits, but flagged the need for continued close monitoring. ESA's SWARM mission, 3 satellites measuring Earth's magnetic field continuously since 2014, has been extended and remains the most detailed real-time monitoring system ever built. SWARM data produced all the major peer-reviewed findings published in 2025. In 2026, NOAA released 2 model versions for the first time: Standard WMM 2025 and the new high-resolution WMMHR 2025. The upgrade was driven by how much more variable and complex the field has become, and global transition to the higher resolution model is now being actively encouraged. Nothing here requires panic. The pole shift will not end navigation overnight, and scientists have stated clearly there is no sign of an imminent reversal. What it requires is informed attention and sustained investment in the systems that monitor and adapt to it. The South Atlantic anomaly is a real documented challenge for satellite operators, and with thousands of new satellites now in orbit, active management of that risk is increasingly critical. ESA, NASA, and private operators are already planning around it. The combined picture is clear. Earth's magnetic environment is more dynamic than scientists a generation ago fully appreciated. We are living through documented, measurable change, and for the first time in history, we have the instruments in space to watch it happen in real time. That is tomorrow's science.